So Caterina is the director of the ALBA synchrotron.
Okay. Thank you.
The floor is yours.
It's a pleasure to participate in this workshop and to continue the already ongoing collaboration in the different committees from ALBA and also from LEAPS, because I am also representing.
Just as a note, I think your voice comes in and out, so maybe you should stay a little closer to your computer so we can hear your voice more consistently.
Can you hear me now? Is that better? Not really.
Yes, that's much better.
It's better.
Okay, I will speak more near. So let me just mention. I want to give a quick introduction on how ALBA started and what is ALBA now, and then I will also spend some time for a few minutes about LEAPS. ALBA is a national infrastructure facility, not like SRF, but fully national, but also with two different owners, which is they are the central government and the regional government. So there is, in any case, this collaboration between two different bodies for the funding and for the support to the facility. This has worked very well from the very beginning. We are national, but of course we are international, not only in the staff, but mainly in the users and in the collaboration we have. Here is a long list that, of course, I will not read through it, but it's a kind of history of what happened before the approval of the facility. Just to say that the idea of having a synchrotron is of the 90s, and of course it came from the scientific community, in particular scientific community is centered in Catalonia, in Barcelona, in the University of the Autónoma. In origin, even they were thinking of doing a collider, but then the community moved towards the synchrotron. And there were, it took almost 1 decade to pass from the very first idea of having a synchrotron in Spain to the approval of the facility. And it was very important, also echoing what Francesco has said, the presence of the scientific community and the interest of specific groups in following up the facility. An important thing that was done also was to ask for economic analysis of the construction of the synchrotron, what would have been the socio-economic impact of a facility. And that was one of the things that helped also in the government to take the decision. So this is something that maybe it could be done. And there have been, of course, evolution also in how to do these studies of the impact. And there is a recent project from Horizon 2020 where there is a model that can be applied also to other infrastructures. If you want, we can speak about that after. And the history of ALBA up to now is started, as I said, preparatory work in the 90s. And then in 2003, the project was approved. Spain was a country where there was not at all any other infrastructure similar to a synchrotron. So there was not experience. And in that case, also is similar to what will happen in Africa. It was a green field and a green country for such an infrastructure. During the preparatory time, there were people who were sent abroad, who were sent to other synchrotrons. There were beam lines built at SRF, so there were people already working in other synchrotrons who were called back when the project started. So this is something also that one should start now in Africa, to send people for training wherever it is possible, and to put already some funding there in training the teams that will be the ones who will build the facility. The facility, the construction started in 2003, 2006 after 3 years of design, and it was ready in 2011 for commissioning. 2012 started the operation. And of course, there has been an evolution since then. Now we are started with 7 beam lines. Now we are building up to the 13th. It is nearby the campus of the University of the Autonomous. The position of a facility is very important. Of course, it must be in a place where you can envisage then to develop the region scientifically and technologically. It must be very well connected with airports, with all roads, because that's very important for the user communities. And here, ALBA was put in the perfect place, according to all these parameters. And it's a 3GB machine. As I said before, we are now going up to the 13 beam line. 2 will be entering in operation next year, and then the 3 others in the next 2-3 years. Highlights, there are many. I just want to mention here one which is obtained with our soft ray microscope, where we can do tomographies of cells, and this is many of the experiments that are done here are done in collaboration with other facilities. And here I give an example in which this study of nanoparticles of iridium for killing cancer cells was done in collaboration with fluorescence imaging. And of course, we have many activities related with environment, as a recent example of photocatalytic water splitting for the production of hydrogen for green fuel. We have activities in the complex materials and related technology developments. And here we have some of the beam lines. There is in particular one beam line, Boreas, which is for absorption and resonance scattering, dedicated to magnetic materials, which is quite unique in this moment in the world. This was also a very an important decision that was taken at the very beginning of the project to build some of the beam lines, which were more conventional, of course, at the most advanced stage in that moment, but conventional in the sense that they had already a community waiting for them. But then to have also some beam lines that were completely new, and they didn't have a community at that moment. But they are now those who are more advanced also with respect to the international. I want to mention just one of the different experiments that have been done related to COVID-19 research. In particular, this one, which is dedicated to the inhibition of the viral replication. And we were giving quick access just from the very beginning. Already after few weeks of full lockdown, we put again in operation the facility in order to give access to those who were doing experiments for COVID-19. And then we have opened the facility to users already in July, even if the staff is not yet all working 100% at ALBA. But we mix teleworking and presence, and we are able to maintain the facility fully running. So this is the past, what has happened up to now. And one important thing is also the evolution of the user community. When the proposal of ALBA was accepted in 2003, there were in Spain 200 people who were using synchrotrons outside Spain. In 2012, in our first call for users, there were already 700 plus 250 international. And now we have almost 3,000 users from Spain and 2,500 from international. So this is an example that when you have to show the importance of having a synchrotron, it's not only who are the people who will be able to use it on day one, but this community is increasing continuously, and the fact that you have this instrument makes many groups, many research institutions, many universities aware of what they can do, and they grow together with the synchrotron. So this is an important for the project of course, here are statistics. I will not go through them, but all the key performance indicators are continuously improving during these 8 years of operation. One important thing is, of course, the innovation capacity of a facility like a synchrotron. Is not only that you develop, you work together with companies to make the enabling technologies for what you need in the facility, but then you offer the beam time to users. And we started with one user the first year of operation. Now we have more than 50 different companies using our beam time directly. Not only that, but there are also the innovation content of the academic research. This was the result you see here, this patent site in ALBA. This is the result of the project I was mentioning before of the impact of a synchrotron from the point of view of economy. There was the study that there were more than 300 patents citing papers which were done based on experiments of ALBA. And this was something that we were not aware of, but it means that in our academic proposal, there is an innovation content that reflects in real patents. So this is very important also. And it's more or less the same in all the synchrotrons. Of course, we are a training center, and here the message to you is use synchrotrons from AfLS from Europe as training centers. We have many collaborations. When I talk of our users, we have more or less 2/3 of our users come from Spain, and 1/3 are from outside Spain, mainly those from Europe, Germany, for example, Germany, France, UK, Italy are common with us. And of course, it's also a center for showing the society what science is for and what is the importance of having scientific institutions and research in any country, in any region that wants to progress. We are, of course, looking at our future. We are planning, following what is the trend in the synchrotron radiation world. The first example you just heard from Francesco, and this is something that ALBA, which is much younger than SRF, will do during the next decade, and we plan to have what we call ALBA 2 around 2030. And we are working on that and doing also some more beam lines, focusing especially in those research areas where we have our strongest contribution. And we will have the space also to do long beam lines that for the 4th generation synchrotrons are very important because we have space around us, and we will use that to make a specific beam lines that in principle will be also connected with a science park. This is a proposal, not yet approved, it's very preliminary, but our idea is to do near ALBA together with a collaboration of several institutions, of the university, of a technology center, in order to have also an optimized use of the new beam lines and of course also. And so we are we are in Spain, and we are one of the members of LEAPS. You know, LEAPS is an association which includes all the synchrotrons and AfL facilities of Europe. We are 19 facilities, 16 institutions in 10 different countries. Some altogether we are serving thousands of users from Europe and beyond. We provide more than 5,000 publications per year. We have in operation more than 300 different end stations, and we have an associate that you will hear later by the director Sesame, and we have also partners which are associations like LEAPS, which is the mirror, but in the neuron sources, or the Canadian research. So there are ways of collaborating with LEAPS that, of course, African Life Salt will come for us a future collaborator of LEAPS. And LEAPS, Europe is leader in the technologies of synchrotrons and of AfLS. In Europe, it was the first fourth generation synchrotron, Max 4. In Europe, the first third generation did the jump to the fourth generation, SRF. We have the highest energy AfL. There is in construction the first AfL based on plasma acceleration. So this is really is the connection between the most advanced photon sources in the world. And we are working together for the future. We are learning from the difficulties of this year due to the pandemic, to build on that, to be resilient, and to perform new advancement also not only in the operation, but in the user service and in the communication, in training concept, all going digital. I'm finishing. And
I think we're over time anyway. So
okay,
thank you.
But in any case, the important message is at the end, we are open to collaboration with.
Thank you very much.